The James Webb Space Telescope notched a cool milestone literally during its months-long calibration for deep space observations. The final instrument aboard the $10 billion James Webb Space Telescope finally achieved its operating temperature of just above absolute zero. The successful cooling ensures that the observatory will be able to probe cosmic objects in infrared light, according to a Wednesday, April 13, statement from NASA's Jet Propulsion Laboratory, JPL, in California, which leads U.S. work on the instrument, called the Mid-Infrared Instrument, MIRI. The telescope has been cooling ever since its launch on December 25, 2021, bringing it to the frigid temperatures necessary for MIRI to accurately detect infrared light, which manifests as heat. MIRI needs to be at a temperature is a little below 7 Kelvin, which is equivalent to -447 degrees Fahrenheit, -266 degrees Celsius. And the complex cooling procedures went very well, thanks lots of practice. We spent years practicing for that moment, running through the commands and the checks that we did on MIRI, Mike Ressler, project scientist for MIRI at JPL, said in the statement. It was kind of like a movie script, everything we were supposed to do was written down and rehearsed. When the test data rolled in, I was ecstatic to see it looked exactly as expected, and that we have a healthy instrument. The temperature milestone is a key moment in Webb's multi-phase, 6-month-long commissioning period to get its mirrors aligned and its instruments ready for deep space observations. Adjustments must be ongoing as the telescope cools, as sometimes the components behave or align differently amid falling temperatures. But so far, Webb's commissioning has pretty much been going to plan. MIRI's key challenge was a milestone called the pinch point, during which the instrument dropped from a slightly higher temperature of 15 Kelvin, -433 degrees Fahrenheit, or -285 degrees Celsius, to the final supercold operating temperature. This pinch point represents a transition zone during which the cryocooler, which is necessary to get Webb to its final temperature, had the least ability to remove heat. The MIRI cooler team has poured a lot of hard work into developing the procedure for the pinch point, Annalyn Schneider, project manager for MIRI at JPL, said in the same statement. The team was both excited and nervous going into the critical activity. In the end, it was a textbook execution of the procedure, and the cooler performance is even better than expected. MIRI's cool temperatures are also required to overcome what scientists call dark current, or the electrical current created by vibrating atoms in the detectors. These small movements can generate false signals in the instrument's data, marring observations. Just to make sure MIRI is behaving properly, the team plans more test images of stars and other objects to test its calibration and performance. Calibration is also ongoing on Webb's mirrors and 3 other instruments as the telescope team aims to finish its work by about June. NASA has said it will hold a key decision meeting late in alignment, once the telescope can focus light successfully in each instrument, to confirm the aligning process is complete. Then will come final commissioning. Providing this all goes to plan, a program of early science, Cycle 1, is expected to start around June, with Cycle 2 operational science expected to begin in mid-2023. Reddits, NASA GSFC/CIL/Adriana Manrique Gutierrez.